Good morning. My name is Ananya Singh from 1 BSc Economics Mathematics, and today we'll study about a topic from applications of derivatives, that is extreme values of a function. So let us start. Extreme values functions. So first, what are extreme values of a function? So basically, maximum and minimum values of a particular functions are called extreme values of that function. It can further classified as absolute maxima and absolute minima, and local maxima and local minima. If we go further, we'll study about what is absolute maxima and absolute minima. The absolute maxima of a function is the highest point in the entire of that particular domain of the function. Basically, absolute maxima is that point in the whole domain of a function which has the maximum value basically. On the other hand, if we take on the entire domain, means in the closed intervals, endpoints will be included, and if we take the minimum point in the whole domain, it will be absolute minima of that function. They are also called global maxima and global minima respectively. If we see the mathematical definition, suppose there is a point C on domain D, then f of C is the absolute maxima of function f if f of C is smaller or equal to f of x for all x in the domain of f. Similarly, if we see absolute minima, f of C is an absolute minimum of f if f of C is smaller or equal to f of x for all x, and the most importantly in the domain f. And you can also see the graph. In this graph, if you take the whole domain including the endpoints of the graph, the minimum value is a, that is f of a. It is absolute minimum of this graph, and if you take the highest peak of the whole graph, that is b, f of b is the absolute maxima of this graph. Now let's see an example of absolute maxima and absolute minima. Suppose there is a function y equals to minus 2x cube. So how we can find the absolute maxima and absolute minima value? So first what we'll do, we'll find the derivative of y equals to minus 2x cube, which will be minus 6x square. Then we'll find the critical point. We find critical point by putting the derivative equals to 0. So the critical point will be equals to 0. So what we'll do in absolute maxima and absolute minima, we also consider the endpoints. So we'll not say that 0 is either our minima and or maxima. First we'll find f of minus 1, means the closed intervals value also, which will be 2, and f of 2 will be minus 16, and f of 0 is 0. So here we can conclude that absolute minima is minus 16, means point of minima is 2. And if we see the absolute maximum value, that is 2, which is at minus 1. So point of maxima is minus 1. You can see in the graph also how we have plotted it. We have taken the whole function including the endpoints. And now let's go upon local maxima and local minima. So what are local maxima and local minima? Simply, for a particular interval, the maxima of the function is called local maxima and minima of the function is called local minima. Simply, if we choose any interval in the domain, in that interval, what is the maximum and minimum value of a function is known as local maxima and local minima. Here we choose a particular interval in the whole domain. Means in a graph we don't consider the endpoints. That is called local maxima and local minima. If we see the mathematical definition, a function f has a local maximum at C if f of c is smaller or equal to f of x when x is near c, this means that f of c is smaller or equal to f of x for all x in some interval containing c. The interval should be inside domain though, but it is not necessary the whole domain should be there. End point shouldn't be there in local maxima and local minima. Similarly, in the same case is with local minima. We can also see the graph here. If we consider the whole domain -1 to 5 in the closed interval, the absolute maxima point will be 5 and minimum will be -1. But if we take a particular interval in the domain, that is 3 to 5, we can see that the local minima is 4 and local maxima is 3. So from this it is clear that what is absolute maxima and absolute minima. Basically, if endpoints are included and the whole domain, we are seeing globally in a function that what is maxima and minima value, that is absolute maxima and absolute minima. But if we only consider some interval in that domain, there's maxima and minimum value is known as local maxima and local minima. Okay, now we'll consider see how can we find out local maxima and local minima. We can find it by two methods. This first, by second order derivative, we'll see. Suppose there is a function fx x cube minus 3x plus 1. First, we all know we'll find the critical points. The critical points will be 1 and -1. So what we'll do, we'll again find second derivative. We will differentiate the function again, and by double differentiation we'll get 6x. Then we'll substitute our critical points in double derivative, and if the f double dash x is smaller than 0, then it is the point of maxima, and if it is greater than 0, then it's the point of minima. In this question also, when we put -1 in double derivative, that is 6x, the value was -6, which was smaller than 0, so it is point of local minima. But if we take critical point x equals to 1 and keep in 6x, the answer is 6, which is greater than 0, then it is the point of local minima. Let's see the same question by different method, which is first order derivatives. As we have already found out the points, critical points, that is 1 and -1. So how we can find local maxima and local minima? By first order derivative. So what we'll do, we'll suppose first for critical point, that is x equals to 1, we'll find we'll take a value which is smaller than 1, suppose 0.9, and greater than 1, suppose 1.1, and keep these values in f dash x, which was 3 into x square minus 1, and we'll see that since the sign of f dash x changes from negative to positive, it changes from negative to positive, means this is like this, means it is point of minimum. But if we consider the second critical point and again take a value which is smaller than -1, suppose -1.1, and greater than -1, suppose -0.9, and put it in f dash x, and we'll see that the sign changes from positive to negative, which implies that it is point of maxima. And when we'll keep these critical points in fx in our function, we'll get minimum value and maximum value. You must be thinking why I have put an aeroplane and a bridge in my first slide. So here we'll come why maxima and minima is important in daily life. It's very common example to find out what should be the maximum height of a bridge. We use maximum and minimum values. And again, for how at what maximum height should an aeroplane take off? We'll again use maxima and minimum value, means extreme value. So extreme values are very much important in our daily life. So thank you. Hope you have learned something from this video.